Good morning, students. Let's start with another model, that is V process model. Again, it is SDLC based model, and we also call this model as verification and validation model. So what is the significance of V here? The first significance is from the word verification and validation, which starts with V, and it is something which is useful in testing, right? So V model is a business oriented model which assists in testing, right? Though we develop the software, but it is more or less utilized in case of testing, because it elaborates how the testing is being carried out and how the documents which are produced in the SDLC, that is all the phases, are being used in the corresponding phases. So the first significance is the verification starts with V, validation starts with V. So we call this as verification and validation model, or simply a V model or VNV model. Now what is verification? Verification is a intermediary step which is used to check whether the desired functionality of a particular phase is done properly or not, right? That is, we need to verify it. We review after each and every step or a phase whether the destined work of that phase is done. Well, validation is something which is carried out at the end once the software is developed, to validate or to test that all the user's requirement, whether functional or non-functional, are properly implemented or not, right? So these verification and validation two terms are relevant to testing only. Another significance of the name V is that when we are going to see the diagrammatic representation of this model, is the phases are arranged in the shape of a V, right? If I just simply show you this, this is what the SDLC phases is, like requirements, then designing, and then coding, and then testing moves upward here, right? So this is what a V model is, because the phases are arranged in the shape of a V. This is the second significance. So now what is this V model? Let's see with the basics. The V model is a type of SDLC model where process executes in a sequential manner in V shape. Okay, again it is a sequential model like waterfall model. It is also known as verification and validation model. It is based on association of a testing phase for each corresponding development stage. Now what does this means is that for each and every testing, whether it is your unit testing, then we have component testing, integration testing, and system testing, acceptance testing. With each of these testing, a corresponding phase of development is associated, which is represented with this dotted arrow. So this is meant by this. Development of each step directly associates with the testing phase. Fine. The next phase starts only after completion of the previous phase. That is, for each development activity, there is a testing activity corresponding to it. So it's clear from here. Let me explain this model once again. Now this is a very important model, right, as far as testing is concerned. We represent the development phases on the left hand side, which is corresponding to the verification phases, because we need to verify after each phase whether the required work of these phases are done properly or not. So we need to verify. Verify means, say you have requirement analysis phase here, so an SRS document will be prepared, right? So once this SRS document is prepared, you are going to verify that the required task is done properly. Is the task of requirements completed as per the customer's requirement? Have we included all the requirements? If it is designing, the design document will be released. So we'll verify that document whether the entire plan or the design has been prepared as expected, right? So we need to verify after each and every phase. While at the pivot or the center, we have a coding here. So this is requirements and then designing. Then the third is coding. We code it in the language whichever is specified by the customer. Once the coding is over, then we start with the testing. Now testing is something which is not represented in a continuation this side, that is you can say in a like waterfall model. We have just reversed the direction of this testing, right, in order to show the corresponding link between the phase and the testing, right. So the levels of testing we are aware of. We have unit testing, we have integration testing, we have system testing, acceptance testing. So we have represented this. So they are a form of validation phases where we are going to test the system with respect to different parameters, right. So this is what the representation is. Now this is one more representation where we are going to show whichever document is prepared after this phase, that is requirement analysis. Like after requirement analysis, we normally know we prepare an SRS document. But what is present in an SRS document? The requirements, that means the acceptance criteria, right. We have to perform the testing at the end to check whether all the requirements in the SRS are met or not, right. That means that acceptance test data is designed in this phase only requirements, which is going to assist in acceptance testing. That means whether to accept the software or not. If all the requirements in the SRS or acceptance test design is properly implemented, the customer is going to accept it, else reject it. Then in the system design, we prepare a system design document. Now what is system design? Where we identify the modules, sub-modules, and a structure is prepared. We call it as a module dependency graph, right. Overall structure is prepared here. So that overall system needs to be tested here, right. So system design, it will be better understood when we'll move on to designing in details, but as of now you can understand it this way. In the system design, we prepare the modules and submodules and we identify input and output parameters. Now the document which is released after the system designing is system test design, which is going to help us in system testing. Now what is system testing? To check the system as a whole, whether it fulfills all the user's requirement. That means all the functional and non-functional requirements are being met, right. And those functional requirements are designed in this. Then architectural design is when we divide our module into submodules. We know that submodules are related to each other. Like say M1 is divided into M1 and M2 and M3. M2 is further divided into M4, M5, M6, right. That means these modules are linked with each other, right. They are a part of some module. They are a sub-part of some module. So that is your architectural design. That means inner level design or a low level design. Then the document that is prepared here is integration test design document, which is going to help us in integration testing. We need to integrate all the modules together so that we can identify the error, that is the integration error between those modules or the interface errors, right. Then is a module design. Module design is where the major modules or the units or the components are designed. That is going to help us in unit testing. So ultimately the documents which are prepared after these phases is in turn going to help in the corresponding testing, and we just have coding at the period. So here we have represented the documents or the deliverables which are released after these phases and how they are going to assist in the corresponding testing. While here we are representing the verification phases and these are the validation phases. Now developers life cycle means SDLC, while testers life cycle is STLC. Software development life cycle, software testing life cycle, right. Just the name is sufficient as of now. So this is what the representation is. Now what is verification? Verification is a static analysis technique that is carried out in the form of a review, which is carried out after each phase. We are not supposed to execute the code here. By just reviewing it, that is by looking at it, we can identify whether the you can say the required task is being done properly or not. Well, validation is something where you need to actually execute the code, implement the code in order to check the runtime behavior of the system, whether it is going to work properly or not. So this is where the actual testing is carried out in order to identify the errors, or whether it is going to fulfill the user's requirement or not. That is checked in validation. Validation is simply testing. So V model contains verification phases on one side, while validation phases on the other side. Verification and validation phases are joined by coding phase in V shape, thus we call it as a V model. That was just significance of V. Now what are the phases? We have already done the phases. Just the first phase is requirement analysis, then system design, architectural design, and module design. So module design is nothing, it's a low level design, while this will be your high level design. Validation phases are unit testing, integration, system, and user acceptance testing. So briefly, while we were discussing SDLC, we have seen these testing phases also. Now what is the principle of a V model? Principle says the first one is large to small. We know that we are breaking our system, the large and a complex system, into smaller modules, and then these, like smaller module in the sense, you can see we are dividing requirement analysis, we identify the modules, we prepare the overall design, then we prepare the architectural design for that. That means subsequently we are breaking our system into smaller parts. Low level design is prepared here, right? So from large to small, so that individual modules can be explored and implemented properly. That means we are going to get more and more details regarding those modules, the minor level details also, not only the superficial view, right? Then data and process integrity. The data and process integrity means, again you can see this figure, the data and process integrity, right? This data is going to help in these two processes. This data is going to help in these two processes. So this is what is meant by data and process integrity. The principle states that the successful design of any project requires the incorporation and cohesion of both data and process. Process elements must be identified at each and every requirement, right? Scalability. The principle states that V model concept has the flexibility to accommodate any IT project irrespective of its size, complexity, and duration. That means it is of any project, like small, medium size, or a large or a complex project. It hardly matters, any of the project, whichever category it belongs to, whatever is the complexity it has, whatever the size it has, or how much duration it will take to, for each and every project, this V model is applicable, because either of the model you use, testing is most important, and you need to test before deploying your system or delivering your system to the customers, right? Then cross-referencing. Direct correlation between requirement and the corresponding testing activity is known as cross-referencing. What is cross-referencing? This connectivity between the requirement and testing, between the designing and system testing, architectural design and integration testing. This is cross-referencing. Then finally, tangible documentation. Tangible means which is measurable in nature, which keeps on changing, it's not rigid. The principle states that every project needs to create a document. This documentation is required and applied by both the project development team and the support team. Documentation is used to maintaining the application once it is available in a production environment. So ultimately it is going to produce again documentation. Now why this model is preferred? It is easy to manage due to the rigidity of this model. Right, we know that whenever we are developing any software, it must be managed properly, because it's a process, and unless you you can say manage the process, it cannot be rigorously followed. So since rigidity is here, you have to follow that sequence, like requirement, designing, testing, then coding, and then subsequent testings. So that rigidity is going to help us in managing this properly, right? Each phase of V model has specific deliverable and a review process. That is also clear. Like we have deliverable means output and review process means verification phases. Apart from this, proactive defect tracking, that is defects are found at early stage. Since the testing is the activity which is not carried out after coding, this is clear from the V model that it is not there. Like in the waterfall model or the previous model, we have seen that testing is an activity, single activity which is carried out after coding. But from V model now it is clear that testing is not a single activity, it is a process which starts from the whenever you start with the requirements, the testing activity starts there. At least the test document, the document which is going to assist in the corresponding testing, is prepared during the corresponding development phase. Like in the requirement, I said we prepare acceptance test document. Then we come is system designing, we prepare a system document which is going to help in system testing. So ultimately what we are trying to do, why the testing starts with the very first stage or the earliest stage as soon as the inception of the problem happens, so that we are trying to prevent the error in the later phases, right? That is why. So it is going to help us in tracking the defect or eliminating or preventing the defect in the later phases. Like as you move downwards here, right? So we are trying to avoid the error so that it is not propagated till this phase, and if you are trying to avoid it, then the possibility of error propagating to the later phases will be less, and thus it will be a successful product since the errors will be least. Now, when to use this V model? When the requirements are well defined, we have proper requirements in our hand which are not ambiguous in nature. Ambiguity means which the requirements, those have multiple interpretations. We don't want those kind of requirements. For example, if I give a term search in library automation system. So what does this search means? It's an ambiguous term. Searching could mean searching a member or searching a book. So interpretations are two now, right? Now what to do? So it becomes ambiguous, right? So we should have proper or well defined requirements, then only you can use a V model, because it is sequential. You don't have a reverse part to go back and make the corrections. The V-shaped model should be used for small to medium sized project where requirements are clearly defined and fixed, right? So though it can be applied to any size, but preferably we must go for small and medium sized projects only, right? The V-shaped model should be chosen when sample technical resources are available with essential technical expertise. Now we want that we have analysts, so he must have the skills of the requirement analysis and specification. So we must have designers, we must have coders and testers. As per the technicalities involved, their skills must match up with that. Now what is the advantage of this V model? It is easy to understand because it like simply follows SDLC, right? Just the order or the shape varies simply. Testing methods like planning, test designing happens well before coding. We know that planning and the test design documents are prepared from the very first stage. So it's not a single activity which is carried out after coding. It is parallelly starting with the development. This saves a lot of time, hence a higher chances of success over the waterfall model, because we are trying to prevent the errors. Ultimately it will be a successful one. Avoid the downward flow of the defects. So since you are carrying out each and every activity properly, you are verifying it after each and every step, so there is a least possibility that there is an error in the each and every phase. So ultimately it is not going to propagate in the later phases. Works well for small plants where requirements are easily understood. Then what are the disadvantages? very rigid and least flexible. Rigid in the sense, again, we have to strictly follow the same order or the sequence, whichever is specified in the model. Not good for complex project, because in a complex project there will be multiple modules, submodules. You have to divide it further, like you can implement it, right? So it becomes difficult, and apart from that you don't have the feedback part also to make the corrections. Software is developed during the implementation stage, so no early prototypes of the software are produced. So what does it mean is, like similar to waterfall model, the working software is delivered very late to the software, that is after testing. Not like incremental or iterative or a prototype approach, where the customer is able to see the working software very early and is more satisfied with that, right? If any changes happen in the midway, then the test document along with the required document has to be updated. So what does it mean is, say you know that changes now and then comes in, right? So you have to make those changes, not changes in the working software. Along with this, you have to update the change in the relevant document that is getting prepared, because finally they are going to help in testing. So these documents must all be also be updated whenever any change is made, because testing depends upon these documents and they must have the recent requirements, right? Or whatever is the data, that must be updated always. So these are the major disadvantages. Just summarizing, कि V model is nothing, simply similar to like SDLC. All the phases are present here, just we have arranged in the form of a V. Left hand side are the development phases, while right hand side represents the testing phase, while at the center you have the coding. In the left hand side we carry out verification after each phase, while in the right hand side we carry out validation. Different types of testing are being carried out simply. Now it is going to help in the testing. Basically it represents that testing is not a single activity, while it starts from the very first phase. Testing activity starts from the very first phase of software development, that is parallel to SDLC. The testing activity starts right now. So hope this is clear. We don't have much detail of this model. Just to understand the business and the testing perspective, we have just studied this model. Go through it once. If you have any problem, we can discuss in the discussion class. Thank you all for today.